All right, it is time for mixture problems. Woo-hoo! Third kind. All right, third kind. And we could even do principal rate time problems. Ooh. All right, so this is the third kind. And so we've done motion problems. We've done motion problems with wind and current. And now we got to do mixture problems. This one's a little bit more difficult to give you a set type equation. But basically, it's the amount times the cost per item, which sometimes will be a percent, will equal the total cost or a total amount or a total of the things. So there's a lot more variation in this kind of problem. Although that's the general idea, and you'll see they tend to go that way. In this one, our chart's going to have 3 rows. Every other chart we had 2 rows. In this situation, because it's a mixture problem, the third row is going to be the mix. So I'm also going to go across from my chart, and I'm going to label the third row as mix. So there are 9 blocks versus 6. All right, a couple of situations. Take your red and circle the word if. If. Is every problem going to involve a pure substance? No. But if it does, you got to know what to use. All right. A pure substance is, all right, for example, let's see, nationalities. Who knows their nationality? Josh, what are you? Okay. Anybody 2 things? Ethan, what are you?
American and English.
Okay, so American and English, and it could be a varying degree. Yeah, it doesn't have to be 50-50, because a parent could be, maybe it does, but anyhow. All right, anybody 100%? Edgewater, what are you? 100% Salvadorian. 100% Greek. Of course, I'm the best 100% because I'm 100% grade A Italian. Viva Italia. All right. So those of us that are all Italian, I'm all Italian. I am 100% Italian. She was 100% Greek. He's 100% Salvadorian. All right. And we're pure, at least. Actually, probably even us somewhere down the line, there's a little itty bit, but after a certain point, it gets jettisoned, and we're still 100%. All right, and 100% in decimal form is 1. So just be aware of that. If you come across a pure substance in a mixture problem, you got to use 1 in the percents. All right, so again, let's go back, fill the formula on top. Usually we'll make the first column the amount. The second column could be cost or percent. I'm going to put percent, but it could be cost per item as well. And then the right-hand side is just about always total. It might be a total cost. It might be a total amount of the substance. All right, so we got the first if out of the way. Be aware of that. Here's a second possibility. Because in this, I don't use the word if, I say the word might. Every blank in the chart might not be filled in. So that's a little odd. Now I'll tell you this, it's usually just 1 can be left blank at times, and it doesn't matter. You can have 1 block that doesn't have something in it. It's usually in the mixed column. we'll do a problem like that, and you'll see it when we get to it. So actually, sometimes you don't need all 9 out of 9 spots. Some problems you do. Some problems you just need 8 out of the 9 spots. Okay? Now, overall, these are similar to just the regular motion type problems in how you proceed. And you'll see that in a moment. Because our last question you should be able to answer. The equations are total equations. You'll like that. Every time the equations are totals. They're not comparison or totals. They're just totals. And come from the what columns? No, what columns? Where do you get the equations from in motion problems? From what columns? From what columns? The variable columns. How soon we forget. You have to know these things. These are what help you to know how to do the problem. Your equations come from the columns with the variables in them. All right? Go back to the first kind of motion problems. Where do the equations come from? You're looking at me like, I've never heard that before. Look how many problems we did. B. The equations will come from, nope. That's I'm in the wrong kind. Only in wind. I just got to go all the way back, as I said at the beginning. How many problems we did already? Oh, my soul. Come on. Come on. All right. The equations will come from the columns that contain the variables. This is the variable columns from which we will get our equations. All right, where am I? Somewhere down the road here. About there. Nope. There. Nope. There. Nope. There. Yeah. All right. So, mixture problem. Difference in the chart, a third row. That bottom row is always the mix. If you happen to get a pure substance, remember, that means you got 100% of it, and therefore it'll be 1 in decimal form, 1.0 if you want. And every once in a while, you can have one blank left empty, and it's not a problem, because guess what? Your variable columns are full. And that's where you get your equations from, right? And in this kind, the equations are always total equations. So that's nice. All right, let's get to it. Let's see what we can do. Example number 1. Cy wants to make an exotic blend of tea. He misses? What in the world is that? What in the world? He mixes. There we go. All right. He mixes. Go ahead, Nick. He mixes green tea at $2.40 per pound with black tea at $1.80 per pound. He wants to produce 4 pounds of the tea blend that will cost $1.95 per pound. How many pounds of each should he mix? And collectively you say, I have no idea. How in the world am I going to figure this out? It's impossible. And it's not impossible. Because we'll break it down into the parts, we'll figure it out. But that's a mixture problem, right? He's mixing the green tea and the black tea. And he's together after a blend of the two. That's what he's after. All right, let's set it up. In this situation, we do have an amount. Right? In this one, we have a cost per pound. Do you agree? So again, if you go back and look at the template, I told you It's going to be an amount, a cost per item, or a percent. That's the cost per item, right? And then the last is the total, right? All right. What would be the next step? Somebody raise your hand and tell me what would now be the next step. Ethan?
Label the mixture row.
Definitely want to label the mixture row. And then what would you do after that? Label the other two rows. You want to label your rows. You have to label your rows. How do you know what to put in any row if you don't know what the row is? Right? Got to label your rows. All right. So somebody tell me what to put for the first row. Top row. What do we put? Andrew, what do you want? Sounds good to me. I'm going Georgia Tech. Green tea, and therefore, what do we got? Black tea for the middle row, Boiler Tech for the middle row. All right, we got green tea, we got black tea. Gee, I wonder what I want to fill in first. Somebody raise your hand and tell me the concept of what you want to fill in first. What do I want to fill in first? Come on, be brave. Caitlin? The variables. Yes, let's fill in the variables. So we better find out what in the world are we trying to find. He wants to produce 4 pounds of tea blend that will cost how many pounds of each? Is how many pounds of each an amount? Is how many pounds of each a price per pound? Is how many pounds of each a total? Which one is it? It's the amount. If we call the green tea X, we're going to call the black tea Y, because we have to call it something. All right. Beautiful. 2 down and 7 to go. All right. Take a look at the problem. Give me just one block. That's what I want. Everybody find a block. Look at the problem. Find a block. There's some nice ones available. So I'm looking for just one block. Nick, give me one block.
240 per pound.
For the which one?
Green tea.
I agree. 2.4. If you want the other O there, stick it there. It doesn't really do you any good, because in the problem you don't really worry about it. But 2.40. That is the price per pound of the green tea. Do you agree? Therefore, everybody knows now we have another block. So somebody give me another block. Lauren, what do you got?
180 for the price per pound for black tea.
180 for the black tea, price per pound. Somebody give me another block. Adam, what do you got?
For the total, it's 195.
What is 195? What total where? The green tea total, the black tea total, or the mixed total is 195? Or the price per pound for the mix. What do you want the 195?
For the green tea and black tea total?
Both of them? So you want 195, 195? And that won't work. But you're thinking, and thinking is good. You got to think. Give me a block. Raquel, give me a block.
For the total for the mixture, it will be 195.
Total for the mixture, so you want me to go here and put 195. I'm just making sure that's what you wanted. Can somebody tell me why that won't work? Andrew?
Because it's not telling you what the total is, it is telling you how much it is per pound.
Doesn't the problem say $1.95 per pound? Where do per pound things go? Don't per pound things go in that column? So how can we get a per pound thing out of its column? If you do that, you're going to mess up, right? Don't get stuff out of... It's why we label our columns. right? All right, so I still need a box. Still need a box. Ashton?
In the mixture, we put 195 per pound in the per pound box.
Okay, so in the per pound column for the mixture is 195, and that is where that goes, right? That is the price per pound of the mix. All right, good to go so far. We need another block. Trying to get somebody who hasn't given me a block yet. Come on, you blockheads, give me a block. Give me a block. I need a block. Come on. Caitlin, didn't you give me one already? Come on, give me a block. Veronica, give me a block.
Total for the green tea is 2.4.
Okay, that is true. I would have held off on that block, but that's okay. Veronica multiplied the x times the 240 to equal 2.4x, and that is correct. I would generally have saved that block to where I've gotten, there's a few more blocks we should have before we do our multiplying out. Josh, what do you got?
4 pounds in the mix amount box.
Okay, so Josh says the amount column for the mix is 4. And yes, it is. Isn't it? He wants to produce 4 pounds of the tea blend, the mix. So that is definitely 4. All right, now let's go ahead, and the green tea is 2.4x. Therefore, class, the black tea is 1.8y. Now here's the $64,000 question. Drum roll, please. And some are anticipating it and grabbing their calculators. What is the total for the mix? How in the world did you figure that out? It doesn't say 7.8 anywhere in the problem. Well, you multiplied the amount times the price per pound, right? Because the first times the second equals this, right? Again, that's why I like having the equal signs there. It just helps trigger the facts of how you get it. All right, chart's full. Good to go. What's next? 2 equations. All right, somebody give me one of the 2 equations. Andrew?
2.4 plus 1.8 plus 1.95 equals
Good try. Not quite. Good try, though. Because you got to think and you got to try. Sit there and do nothing, you'll go nowhere. So you got to try. Somebody else try one. Raquel. So you're going to make a comparison, huh? How about if you go back and read that right there? So I'm trying to save you from that, but that's okay. We just started, so things don't sink in completely the first time. Still looking for an equation. Adam.
2.4x plus 1.8y equals 7.8.
Ding, 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 ding. 2.4x plus 1.8y equals 7.8. Yes, it does. The total amount of money of the green tea plus the total amount of money of the black tea gives you the total amount of the mix. That is true. He got his equation from a variable column. Somebody give me the other equation. John?
X plus y equals 4.
X plus y does equal 4. And we get that from the amount column. X plus y does equal 4. Those are our 2 equations. They're always total equations. The totals always equal the mix. That's nice and easy. Makes life quite easy. All right. So when you start doing a few of these, that gets to be same thing over and over again, and it sinks in a little more. Okay, now we're at the point where we have a system of equations, and we have to decide what method we'll use to solve it. Who can raise their hand and tell me the 3 methods we've learned, all 3, of solving systems of equations? Adriana, thank you for volunteering. Yes, what are those 3 methods? And graphing. And graphing we usually don't do unless we're told to graph, right? So, are we going to solve by substitution, or are we going to solve by elimination? Look at this problem and figure out which one is easier. Adam, what do you think?
Elimination.
I would not go elimination on this problem. I would definitely solve by substitution. It would be hard to get the x's to be equal and opposite. You'd have to multiply the bottom by negative 2.4. It would be tough to get the y's to be equal and opposite. You'd have to multiply the bottom by negative 1.8. I mean, you could do it, but you got all these decimals everywhere. However, substitution is real easy. What do you get if you solve the bottom equation for x? You get x equals,
4 minus.
you got to add a negative y to both sides. You get x equals 4 minus y, right? That's so easy. You just add a negative y to both sides. All right, now we're ready to sub that in. All right, at this point, I'm going to pause. I want you to finish the problem. All the way to the end, answering the question. Make sure you ATQ answer the question. All right, I don't know where you ended up. But substitution, you'd sub in the 4 minus y for the x of the first one. When you did, you should have gotten 9.6 minus 2.4y plus 1.8y equals 7.8. By the way, I will tell you this. Some people at this point say multiply everything by 10 and get rid of the decimals. You know what? If I didn't have a calculator, maybe that's what I would do. But we have calculators, don't we? And so, again, we're just going to punch it in the calculator. You do have to be careful with decimals, though. So your next line, when you would have added the negative 2.4 and the positive 1.8, you should have gotten negative 0.6 of the y's. Now add a negative 9.6 to both sides. You should have had negative 0.6y equals negative 1.8. Divide by the negative 0.6, and you should have gotten y equals 3. You should then go to your chart and say, what is y? Well, y is my black tea, and what are the units of y? And y is in pounds. So 3 pounds of black tea. How many had that? Okay. 3 pounds of black tea. And now I got to finish the problem. So again, remember a little thing. I tell you to circle the equation when you solve it for that variable, because now if you use your circle equation, it's easy to find that second value. Now I'll sub in the 3, and I get x equals 1. Again, what is x? It's an amount of green tea. It is 1 pound of green tea. How many got the problem correct? All right. Look at that. You did the problem. I thought word problems were impossible. All right, now here's the issue. How many things do you have to get correct to get one of these things correct to the end? Like 40, right? I don't know. It's a lot. There are a lot of steps to getting the bottom line correct answer. But they're doable. You do have to be careful, because you don't want to have to restart all over again. Be careful. Just be careful. When you get down to the calculating, be careful. Take some time. Use your calculator. You got a calculator. Do you know how to use the plus minus button on your calculator? I hope you do. Turn a positive quantity to negative so your calculator deal with it. If you not know how to work that, use a parentheses, but you need to know how to work your calculator. Now, I purposely did not finish this. We have one more example we're going to work on Monday. Okay. There's no homework over this yet today. Wait a minute. Is there? There is. There is. Snow day. Actually, it changed. All right. This is the snow day change. Make sure I get this correct. I still. I gotta stop